Hello, I'm Sujata from CBSE NEET JEE Chemistry.in. In this video, we will learn how to apply the use of alkenes in the preparation of ethers through the formation of a stable carbocation. You will see this question and its variations in many exams, and understanding this will give you a definite advantage. We have an asymmetrical alkene made to react with ethanol in the presence of H plus acid gives you X. What is the structure of X? So this is an asymmetrical alkene with ethanol in the presence of an acid. So let's see how this reaction progresses. Alright. So first you have to consider the asymmetrical alkene in the presence of H plus. Alright. So the pi bond will obviously shift to the pi bond if it shifts to this carbon atom. So there are various ways in which this pi bond could shift. Two ways. The pi bond can shift to this carbon atom, making this carbon atom negative, and the hydrogen ion gets bonded to this carbon atom. Therefore, this carbon atom becomes positive. So you get a secondary carbocation. In earlier examples, it has been highlighted that whenever you come across a carbocation as an intermediate in the course of your reaction, make sure whether it is possible to convert the whichever carbocation you have got, primary or secondary, to a more stable carbocation. So right now we have got a secondary carbocation. Let's write down the reaction in detail to check whether we can convert a secondary carbocation to a more stable tertiary carbocation by some kind of rearrangement or shifts. That will help us to arrive at the final product X. Alright, and then we will see which of these options will correspond to the identity of X. So, we have the asymmetrical alkene 3-methyl-but-1-ene in the presence of H plus. I am not discussing the entire mechanism. So basically this is, instead of ethanol, right now you have ethanol. So imagine the same mechanism that you did for hydration of an alkene in the presence of an acid catalyst. I am not getting into the details of that, but yes, first is the addition of H plus. H plus can add on to any of these two carbon atoms across this double bond, right? In other words, the pi bond can shift to this carbon atom or to this carbon atom. We prefer the shifting of the pi bond to this carbon atom so that you arrive at a secondary carbocation. Otherwise, if this pi bond had shifted to this carbon atom, you would have got a positive charge here, CH2 plus, which corresponds to a highly unstable primary carbocation. So right now, this has shifted here and we have got a stable secondary carbocation, right? Now, whenever we get a secondary carbocation, before we continue with the reaction, we have to check whether it is possible to convert it into a more stable carbocation. So, look at the adjacent carbon atom to check whether any kind of a shift is possible. So, here we have on this carbon atom, we have a hydrogen. So, if you replace, if this hydrogen along with the bond called hydride ion shifts to this carbon atom positive end, it's called the 1,2 hydride ion shift. That will result in a very stable tertiary carbocation. So in this manner, we have arrived at a very stable carbocation. Now the tertiary carbocation will now interact with the ethoxide ion. The ethoxide ion will be attracted to this positive end to give you the corresponding ether. Alright, so this corresponds to option B. This is how you carry out the entire reaction. So highlight here is the transformation of a secondary carbocation to a more stable tertiary carbocation by a hydride ion shift. Alright, so option B is the correct answer. Option B is the correct answer. We have over 230 videos with in-depth explanation of concepts in an easy and lucid manner in our organic chemistry course. Moreover, we have close to 400 videos of solutions to every kind of question that can be asked in any exam. Click the link in our description below to check out our course. Subscribe to our channel to regularly get new content to help you score high marks in chemistry.